Why are we here? Sysmon for the masses. I really like this talk because I'm very much an offensive person when it comes to, and I don't mean that from like swearing and things, but more so from a understanding attack patterns and being able to attack organizations. It was funny, one of my friends holds a kind of a conference just for a small group of people, like 10 people, and we just went there, and he had created this whole simulated environment, and it was really neat. Let me back up a second. So it starts off with his name's Tom Liston. He's been working for Firma. Everybody familiar with Firma? The Firma agency does a lot of the Hadron Collider stuff. You know, I don't know, it's like a bunch of sciencey stuff that you blow stuff up and things. You know, and you figure out particles. Anyway, like the particle accelerator stuff. I think it's like a smaller particle accelerator out of Chicago. Anyways, Tom goes to me and he's like, "Hey, I've been doing some pro bono work for Firma, and I need your guys' help because we have a major problem." And he starts off with it real serious, you know, so like it's just like a super serious thing. And so he's like, I have this paper here that authorizes all of you to help us out with this specific problem, and it was actually like a fake Firma, you know, document or whatever. And he's like, so here's the issue. He's like, when E equals mc squared, when mass equals energy and all that good stuff, he's like, they found out that it's not always 100% the time, and that there's a little bit of energy that bleeds off and goes into time, basically, and you can basically go back in time and send messages back in time, which is obviously all fake and crazy. But at the time, we're like, this is kind of weird. And he's like, well, if you don't believe me, here's a hash, go to your emails, and I go to my email. And a month ago, he had sent us an email with a hash value at the very bottom of it, a hash value that was MD5. And it was a specific hash, and he's like, okay, so everybody write 8 digits on a random card, and I'll type it into the Firma thing, I'll send it back in time, and it'll be this hash right here that I gave you a month ago. I can't obviously change it. And so we all typed it in, and we all did random ones. We typed it in and generated this PDF. You open up the PDF, and there's all of our random numbers in there, and he sends us the PDF, and we all hash it in ourselves, and the hash value matches up. That's really weird, right? So like that's freaky. And so he's like, well, here's the thing. And so he's like, the main scientist that was running this Firma project has gone missing, and we need to go figure it out. And so I got to hack into a fake website, and then from there get into his backend infrastructure, and then hack into that, and further compromise everything. And I was the one that was just kind of like ripping and tearing into everything that was offensive. And long story short, he was using MD5 hash collisions and was able to predict each spot inside the PDF that there would be a hash collision, and could generate his own PDF that had any numbers that we wanted to in it with the same hash that was in there. Really, really cool. But from the offensive side, that's where I find a lot of my time at. But Sysmon is a lot different. It's very defensive. And so one thing that I get to do a lot of binary defense with these folks over here is understand and learn a lot about what kind of artifacts and remnants that I leave as an attacker. And I'll talk a little about some of the latest attack vectors that I'm seeing out there, the ones that are very successful for us that most companies don't really have any, if at all, any defenses of even looking for. Most companies are still looking for executables and binaries from like an antivirus perspective, and others. Others are looking for PowerShell exploitation, but most aren't looking for what we call living off the land binaries and scripts. And we'll talk about what those are and how attackers leverage that from an exploitation perspective, and how we can start to leverage things like Sysmon to help us out get a little bit better on detection. Sound good? And if anybody has any questions, by the way, feel free to raise your hand, ask questions, or shout it out, or tackle me if you disagree adamantly. Charles probably knows more than me than Sysmon, so he'd probably correct me a couple times. So just some statistics here really quick. When you look at how attackers break out and where we have the most amount of our damage, when attackers compromise an organization, there's a very small time window of when that compromise occurs to when an attacker tries to move laterally across your environment to get access to the data that they want. So you'd say, okay, a user opened up a PDF. A good example would be Starwood. You go historically on Starwood, user opened up a document got compromised, China had access to a specific database that they laterally moved to, had access to it for, was it 4 years, 5 years, something like that? Had multiple years where they had access to everybody's hotel bookings, when they're booking it, basically personal information to be able to track people as they're leveraging Starwood hotels. And so those time periods are really critical for us, because if we don't detect that initial intrusion, and we don't detect that lateral movement, we have a major problem, because attackers are leveraging our network and our infrastructure to have access to the data that they need. And so if you look at some breakout statistics, roughly around 2 hours is about all the time we have as defenders to identify that initial compromise before they start to break out and move to different systems. And that could be through grabbing the local admin accounts on the box itself. That could be grabbing clear text passwords out of memory. That could be leveraging a Kerberos token that's valid on the system. there's a number of different methods that we as attackers use. And if you're not familiar with clear text passwords out of memory, hopefully everybody's familiar with Mimikatz, but there's an undocumented feature inside of LSASS called wdigest, which allows you to extract clear text passwords out of memory, which Windows isn't really supposed to do, but it does it from a legacy perspective to leverage browser compatibility support for authenticating to sites. And so what will happen is when you go to log in with your username and password, that password's actually stored in a portion of memory, and then it compares it to a hash value to see whether or not that hash value is legitimate, and then you log into the system. And so as part of that, again, we have multiple methods that we leverage for compromising and attacks. If you look at most of them, initial compromises were due to macro attachments and malicious websites. So macro attachments and malicious websites. Anybody here been able to get rid of macros across their entire environment yet? Anybody? Not one? Yeah, figures. Sometimes there's like that one person, I ask them, like, how many people do you have in your company? They're like, well, 7. I'm like, okay, well, that makes sense. I understand that, right? The world would be a lot easier if we had 7 people in our company, right? And so you look at these breakout timeframes and you start to break down some statistics. And if you look at some breach compromises, 82% are still executables and binaries because those are still effective. If you look at Fin7, which was one of the more organized groups before they got busted and thrown in jail, they had this RTF 0-day that they use all the time, a rich text format 0-day. And even though they had a 0-day that gave them full remote code execution, what did they do? They downloaded an executable and ran it because it worked on all their customers that they were attacking. Right? So executables still to this day are very much a problem for us, and it's usually to users going and downloading things that they shouldn't be. Look at the other 14%, well, it's 18%, but 14% of the 18% that's left is PowerShell exploitation. And PowerShell is definitely still one of these things where we as attackers leverage on a regular basis, a full-fledged programming language. Funny story just today, Jeff Snover is the guy that created PowerShell. And he's a good friend of mine, and so is Lee Holmes, who's basically the father of PowerShell security, basically built in all the security. And I was talking to Lee today about DerbyCon, and he's like, hey, I'm thinking about doing a presentation on how you kind of kick-started the PowerShell security movement, in PowerShell. I gave the very first ever, with a guy named Josh Kelly, who I worked with at Diebold, the very first ever PowerShell security talk, talking about how they're going to start to incorporate a full-fledged programming language and the kind of the ins and outs of that. And so Lee actually sent me all the initial emails that I had sent Microsoft to them originally. I thought that was really cool historically, and I'm like, and I sent him a message. I'm like, hopefully I didn't sound like a dick, when I was talking to you. So he's like, no, you're really nice, you're really awesome. I'm like, okay, cool, all right. So I was very professional in those emails. I went through them all, but PowerShell exploitation definitely still a big one. The last category, and this is where we start to see a lot of the tailored attacks. When you start talking about nation states or even more of the higher end ransomware campaigns, the living up the land binaries and scripts is really where a lot of the research is going into. And the reason for this is that it's something that's going to last us a long time. When I used to hack 10 years ago, I still hack now, but 10 years ago when I was hacking, I would think, well, what things do I know a user has in their environment that I can use to attack? I knew that they had Office, right? I knew they had PDFs. So I try to find 0 days in Office documents. I try to find 0 days in PDF documents so that I could send an attachment to them to go and compromise them. Things have changed a little bit. It's a lot harder to write 0 days and burn them specifically on customers too. And also you can get like $1 million for those if you submit them to Apple or Microsoft, so it's not worth burning on a customer. And so you look at that and you say, well, what other methods can I use to get remote code execution on the system as an attacker? If I'm going to phish somebody and they're going to believe my phish, what can I do on that system? And what are the things that I know will be on that system in the first place? Well, I know that they're going to have PowerShell, but people are focusing on PowerShell, so I might get busted when it comes to PowerShell. Maybe I can obfuscate my code or encrypt my code in some way, shape, or form to get around it. That's kind of a risk. So this is where we start getting into the discussion of living off the land, binaries, and scripts. And there's a great project by one of the folks over at Trusted Tech called Oddvar Mo. He's out of Norway. Believe it or not, we're international now, which is crazy. We have folks in UK, Norway, insane. But Oddvar is running this project, and this is the central, biggest, authoritative place on living off land, binaries, and scripts. So if you want more information on that, it's walbass-project.com. And what these are, and it was first coined at DerbyCon 3 by Chris Campbell and Matt Graber. And what these are is that, and there's, by the way, just at DEF CON, just recently at DEF CON, they came out with a Linux living off the land, binaries, and scripts. So there's a Linux project now for these as well, and so is there for OS X. So these are all things that ship with Microsoft, and why this is important is some companies do application whitelisting or application control. They basically say, well, is this an executable that I've seen before, or is this code signed by a publisher that I trust, that I've previously seen that I allow in my environment? And in those types of environments, it's difficult for me. PowerShell is still a viable option, but I can't just drop an executable onto a system to get remote code execution. And so what I have to rely upon is things on the operating system that may allow me to compromise the system, that maybe abusing a certain function in the operating system that it wasn't intended. And so what these are is basically an application that's on Windows that is code signed by Microsoft, that is validated and code signed by Microsoft, and ships with the operating system by default, and has additional code execution functionality in it. So for example, like calc.exe, lsas.exe, explorer.exe, winword.exe. These are all applications that are code signed by Microsoft that are code signed and are validated by Microsoft, right? We use on a regular basis. Well, the operating system also has other binaries that allow the operating system to work. When you have to import a DLL, how do you do that? Well, run DLL 32, right? There are a number of applications in the system that give us functionality. Now, there's about 77 of these total that have been identified so far that basically have one function, but also allow us to do something completely different, and that is remote code execution, and it's very difficult to identify. So it's code signed by Microsoft, which means that your application whitelisting tools aren't going to block it, and we have the ability to run certain commands that allow us to then go and download code directly from the internet, unauthenticated, execute directly in memory without any trace or logs. And so there's a number of these out there. regsvr32 is probably my favorite. That's probably one of the most prominent ones that's used out there. That's under System32. Every Windows system has regsvr32. And regsvr32 has a /i parameter where you can give it a certain website. And it'll go to that website, download a scriptlet object, and then execute that code directly into memory. And so why it's important is it's also proxy aware. So if you're leveraging proxies and things like that, it automatically goes out and downloads the code for us, executes it, and runs. So there's a lot of these out there that allow us for code execution. So if we, for example, get somebody to open up an Excel document, we don't have to call PowerShell. We don't have to call command.exe. We don't have to call a lot of the things that you would flag on us on. We can call one of these living up land binaries and scripts. And by the way, there's code signed scripts that have the same functionality that give us full access to the computer that most folks aren't looking at. A good example of tripping up attackers, by the way, one of our guys, Jason Lang, was on a red team engagement recently. And we have this tool that we've developed called Scoutmaster. We have a whole research division at Trust Sex dedicated just specifically to basically becoming non-detectable. And so we have a number of undocumented deserialization techniques, code execution techniques that haven't been published. And so we're doing a long-term red team for a really high-end customer that had a really, really good security program. And we got access, after about a month's worth of work, got access to remote code execution on this person's computer, undetected. About 5 minutes later, we got detected. And we're like, what? Nothing that we have on here will get detected here. Like, we're good. We know we're good. What happened? And it was interesting enough, this company had baselined their users and said, these people are technical, these people are non-technical. And we were on a non-technical machine, and Jason had typed in ipconfig just to see what network he was on. And ipconfig triggered an alarm saying, this person's non-technical, why would they ever be running an ipconfig, and then investigated and busted us. Thought that was really cool, right? So there are ways to trip us up even if you don't detect this type of stuff. When it comes to detection, one of our biggest challenges are our endpoints. Getting those logs, the volume of those logs, getting the information off of those, being able to identify what's actually happening on those systems and baselining behavior. Those are some of the big things that we really struggle with, just in general in environments. And so some examples of this, and let me skip forward real quick here. I should have the slides. Actually, let me reorder the slides real quick. I did all the slides today, so. Typical Dave fashion. Let me just get this really quick and move this up here. Right there. There we go. All right. So here's an example of living up land binaries and scripts. So we have regsvr32, and we go to /i, and we give it a specific SCT file, which is a scriptlet object. And here's just an example of running calc. And so we can run calc from here, but we can also run any full code we want to, PowerShell code, anything that we want to on the system itself. So what we would do is embed this in a Java applet, embed it in an Excel document, embed it in a Word document, have that person open up that document, and all of a sudden now we get unrestricted access to this computer just by opening it up without calling PowerShell, without downloading a binary, without doing all the crazy stuff out there. Another really good one is MSHTA. This is probably one of my favorite ones because it's so simple. With MSHTA, there are file types called HTAs, or high content HTML files. why HTAs are important is if you give a file, if you go to your index of your source code of your website that you're running, and you give it a source of a launcher.hta, most browsers, Chrome, Firefox, Internet Explorer, when you go to a site that's serving up an HTA, it's a launchable extension inside of a browser type. So what will happen is it'll pop up saying, do you want to open this file? And if you hit open file, it calls msht.exe, and in there you could have your scriptlet files that then compromise the system. It's kind of like a Java applet, but built into Windows. So there's a lot of ways that we, again, compromise your system. In this case, we can also use mshta, which is under your System32 directory, to call out directly to any website that we want to, download an SCT file. It doesn't need to be an SCT, we .txt as long as it has the scriptlet tags in it. Execute, and then from there, have full access to your computer, and then compromise it from there. Another one using WMIC. Using WMIC, we can, again, go out to the internet, download a file directly, and have it execute directly on the system. There's a whole bunch of these, cbd.exe, csc.exe, mavinject, bginfo, msbuild, the list goes on. There's a whole bunch of these that we can use for remote code execution. Another example, certutil. Are you familiar with certutil? Certutil, you have the ability to import and export certificates, right? There's also this awesome URL cache and split functionality, which you can download any file from the internet. Fantastic. We saw this in pretty awesome malware. Daniel Bohannon from FireEye actually found this in the Flare team. And it was certutil going out to the internet, downloading a PowerShell code, and then having PowerShell execute it. And the reason they're doing that is because a lot of people will look for PowerShell communicating out to the internet from an indicator's perspective. But if PowerShell is just running PowerShell code without ever actually going out to the internet, is it actually going to generate an alarm in your environment? Probably not. So a way to use certutil, grab that code, set it as a variable, then call PowerShell, have PowerShell code execute based off of certutil. So it's kind of a chained attack, which I thought was really kind of neat out there. So those are just some basics of living off LAN binaries and scripts. Now, how do we detect these types of things, okay? One of my favorite methods is Sysmon. Now, when you talk about Windows logs, out of the box, most of these attacks are not going to be seen by Windows logs. You can maybe leverage something like process create, which is what, 4688, I believe. And so with process creation, you can see these processes getting created, but you don't necessarily get to see, and it's a group policy setting, you don't necessarily get to see what it's doing. So how do we get this information in some way, shape, or form to us that we can then build rules off of to then go and detect? Obviously, you can go with binary defense, right? Because we detect all this stuff. I'm just messing with you, there's a little plug in there. Or you can leverage your own type of way, and with Sysmon. Sysmon is a free tool from Microsoft. It's made by the guys from Sysinternals, Mark Rusanovich's team, and it exposes something called Windows Event Log Tracing for Windows. Not Windows Event Log Tracing for Windows, it's Event Log Tracing for Windows. Kernel level Windows Event Log Tracing for Windows. And so ETW is a way that exposes essentially kernel traces that allows us to identify things that are happening on the system that you might not have. And when you install Sysmon, it's an agent. It's about 8 megs or so of RAM. And when you run this agent in your environment, you can supply a configuration file. And in that configuration file, you have the ability to say, I only want to look for these specific things, and I only want you to log these specific things. And you can do and/ors. You can do things that allow you to nest different commands, or say, I want both network communications and this to happen. You can essentially build your rules out to allow you to do a lot of great detections through ETW. You can do things like detecting mimikatz. You can do things like process injection, where somebody's allocating memory from one process to the next process with create remote thread. You can look for things like process hollowing, which is a combination of 3 or 4 different events. You can look for these living off LAN binaries and scripts. There's a lot of different things that you can do to identify. And with version 10.2, well, with version 10, they just incorporated DNS as well. So you can now add things like DNS and look for DNS events that are happening in your environment versus having to pull them off from multiple locations. So some great ways there. One thing I'll say, just from experience, Sysmon on servers, maybe not so good. Sysmon on workstations, fantastic, stable, no issues at all. One of those things where very heavily. There was a lot of problems back in the past with Sysmon, specifically with conflictions with like McAfee and Symantec. They didn't play so well together. That's been long since addressed for about 1.5 years or so, and a very stable way to deploy it. And so it's an agent. You can script this, deploy through group policy. You can give it its own config. You can go then and then use something like Windows Event Forwarding to offload it to Sysmon, or if you're using something like Snare or other things, or your SIM, whatever your SIM is, grabbing those specific Windows event logs. And I'll walk you through what that is.
What do you like better for servers? If it's not stable?
When the consumption of memory and usage and the stability is a problem. We have definitely seen with Sysmon.sys, the driver, or Sysmon.drive, that it'll blue screen servers every once in a while. So very rare, unusual occasions, but it's to the point to where we don't deploy Sysmon on servers anymore. Yeah.
If your server's like really like low load, you can do it, but if it's anywhere near like medium to high load,
Yeah. Yeah, on Active Directory domain controllers, no way. On maybe member servers that don't have a lot of functions, probably not a problem. Server 2008 R2, major problems with blue screening there. Haven't really seen it too much with Server 2010, but Server 2008 R2 for sure. Good question. Downloading Sysfon, download directly from the Microsoft sites. As of the 27th, there was the latest version, 10.2, had the latest version of Sysmon. I'm going to walk you through some installations, but basically when you download this file, there's going to be three things in there. The EULA, which I'm sure everybody will read inside and out. Then you have Sysmon and Sysmon 64. Now the big misconception is that if you're running on a 64-bit operating system, you need Sysmon 64. That's not true. You only need Sysmon.exe. Sysmon.exe is 32 and 64-bit compatible. Sysmon 64 is only for things that are for systems that don't have any type of 32-bit compatibility in them. So like Windows Core, things like that. If you're running something like that, you'd have to run Sysmon 64. So for all intents and purposes, you'll be running Sysmon. And basically when you run Sysmon, you'll see all of the different options in there. When you go to install Sysmon, you just do Sysmon-exe, Sysmon.exe-i. That will install Sysmon in its default logging text, its default configuration. It only logs a subset of things. Then you do Sysmon -c, and you can give it a configuration file. Now, obviously, you can script all this out. You can deploy it via group policy. There's a lot of ways that you don't have to run this on each individual one of your systems. Let's get into it a little bit. So, if I go over to my box here. If you notice here, I have Sysmon right here. I'm just going to type Sysmon. Here, we have all the information that we need here. One thing that's interesting is that Sysmon does not need a reboot. Hypothetically, it does not need a reboot. Sometimes it gets in a stale state and sometimes you need to do it, but most cases you don't need a reboot. So there's Sysmon-i, just install it. Notice here, it's installed. Sysmon is now installed on our computer. Bada bing, bada boom. If we go to Event Viewer, and we go to Application and Service Log. And we go to Microsoft. There'll be a new folder there for us called Sysmon that gets created. So Microsoft, Windows, and then Sysmon. So now we have a new operational log with everything that's going on within Sysmon. So we can see all the Sysmon events. Now obviously we can export this off for us, but right now we're just configuration. We first need to know what we want to do, so we'll go ahead and create a config really quick. And I'll show you some great examples of already started configs mapped to things like the MITRE ATT&CK framework, already started configs that already have predefined detections in them for living off the land binaries and scripts, some great research projects. So I'll show you that at the very end of the presentation. But here's an example of one. And what we're going to do here is we're going to use process creation. And this is what we call event ID 1. The way that Sysmon breaks things down is into different event IDs. Like for example, image load type 7 or event ID 7 is when a DLL is imported in or an image is loaded into memory. So for example, Mimikatz, public knowledge of this, I'm not giving away any secret sauce, is that vaultcli.dll, which is a cryptographic library used every single time inside of Mimikatz, whenever you see that imported from processes or processes that are suspicious, like excel.exe, winword.exe, command.exe, PowerShell.exe, probably a good indication that somebody's importing in Mimikatz and leveraging Mimikatz in your environment. One of the more better ways of identifying Mimikatz out there. But in this specific case, what we're going to be doing is we're saying Sysmon schema is saying what version of Sysmon is this configuration file. It has backwards compatibility if you're using older versions versus new. We just need to define that. This is 4.2.1's the latest. We're using MD5 and SHA hashes for the hashing algorithms for when it does comparisons for like executables and things like that. We're going to start event filtering, which means that start to capture information and record information on the system. Process create on match include. We can exclude things as well, by the way. So if we want to exclude certain things, you can exclude. But on match, when a process is created, look for image condition ends with regsvr32. So we're looking for anything basically, you can say contains as well, by the way. It ends with regsvr32, okay? We're looking for regsvr32 in any capacity whatsoever. One thing I will say is that in most normal environments in Windows, you're not going to see regsvr32 ever really kicked off by a regular user. If you see that, stuff's about to go down, right? And so you know that if you see that in your environment, it's pretty bad. One thing we can also do, as an example, is we can say command condition equals contains a /i. Remember we needed that /i to go out to the internet with? It'll go forward and look for that specific area. Now I will caution you on looking for that /i. The reason for that, there's many ways for us to obfuscate our command line arguments to get around that /i detection. So when I develop these types of rules in Sysmon, if they're high fidelity ones like regsvr32 or MSHDA, I'll just say, listen, if I see process creation started at all with these two, I want to know about it, period. And then I can put exceptions in for certain machines that maybe actually call, which is very unusual and rare in your environment to see these. So be careful and cautious on how you're actually filtering. Like for example, if I do a /**************, I, what happens? Is it going to hit this? No. Is that still going to work on the command line? Yes. So there are ways for us to obfuscate our command line auditing ways to get around these detections. So be careful again on the command line audits. In addition, you can also set variables. So I can set a variable to be /i, and then run the variable in that regsvr32. There are ways for us to kind of manipulate and work these specific ones out. So let's go ahead and create this config. So if I copy this, and by the way, I will share the slides with everybody. So at the end of this, I'll give it to Justin. Can we get out to the distro list for everybody? So if you're on the NEOISF distro list, it'll go out to everybody for the PDF for the thing, so you have all of this. So I'm going to go ahead and save this. Excuse me. And I'll just name this testing1.xml. Now that we have this config, if we go back to our command prompt, which I apparently just exited somehow. Did I exit it? No, it's right here. And I'm going to do -C. I'm going to do testing1.xml. Notice here, configuration file validated, configuration file updated. That's exactly what I want to see. It means I didn't have any typos when I was frantically doing this earlier today. Fantastic. Now we're ready to go. We don't have to reboot. We don't have to reload anything. It's ready to go to listen to our config. Now let's go ahead and run a malicious command. It was up here earlier, right? Right here. So I'm going to run this fake command, which isn't going to go to anything, and I'll just go to like binarydefense.com just in case. So if example is actually hosting malware, it doesn't compromise my box.
You don't know what we got up there.
Yeah, you don't know who owns it, right? Yeah, you don't know binary defense is either, right? So we'll go to here, we'll run this, and Windows Defender picked this one up. Now, interesting enough, there are ways to obfuscate against Windows Defender. Notice that one gets around it. So, good job. I'll turn Windows Defender off really quick, just as an example. Browser. All right, I run this again. All right, I run this. Now if I go to my event viewer and I refresh, notice here, we get event log here created with the image that was loaded, so regsvr32. Notice here, we get the full command line of what was actually running, the context of the user itself, and any additional information, the hash value for it and things like that. One common trick that I will use, by the way, I will use matches a specific hash, and I'll look for anything that calls the MD5s of PowerShell not in their appropriate directory. Because a lot of tools, you can rename PowerShell.exe to like moo.exe, and nothing will detect that it's actually executing or running. So some common techniques that I'll use as attackers. But notice here we have a parent image of command.exe. Well, that's not suspicious at all. Command.exe spawned a child process of regsvr32 that's now beaconing out and downloading a scriptlet object out to the internet. Great correlation rule right there, and something very simple that we just created within a couple seconds, right? That's one. So let's go a little bit further. So here we install that, and you saw that, and then that's the event logs. There's us running the command itself, and then it's the event log ID that's actually generated. Now let's do a different one. What about things like PowerShell? PowerShell is a great example of something that I would want to know anytime it's speaking out to the internet. And now here's the question: if I look for any PowerShell code that is speaking out to the internet, are we going to have false positives? Heck yes, especially Windows telemetry data. That is a bunch of noise that you don't want in your environment, believe me. That stuff hits on every system and every server and every workstation in your environment at the exact same time. Nothing wrong with that. I'm sure that's not going to overload anything at all as you're getting 10,000 events, multi-part messages coming to your environment at a given time. Speak on experience in that one. But what we can do is look for PowerShell, and we can exclude certain things. PowerShell is a great example, and this is what I get more towards understanding behavior. I'd want to know every time PowerShell is going out to the internet, and I'd rather exclude ones that I know are legitimate and baseline my environment and my traffic, so I can see things that are happening across my environment. So every time that PowerShell beacons out, I don't care what the command is. I know that it's using a network connection communicating out to the internet. So in this case, we're going to morph the regSVR32 just a little bit, and instead of looking at process creation, we're going to look at any time regSVR has a network connection. So now we can look at network connections and say, okay, well, regSVR32 communicates out or uses any type of network connections. I want to see that as it's happening. Another good one to check for, WMIC. Should WMIC ever be connecting out to the internet? Should MSHT8IDXE ever be connecting out to the internet? Should MSBuild ever be connecting out to the internet? These are all common ones that we could detect that are being used right now in your environment, so you probably have little to no visibility into for many pieces. So let's take a look at this real quick. I'll copy this new config, go over to here, and I'm going to do a couple different options here. Now, I'm going to show you something interesting about this one that I think is kind of bogus. I wish they would fix. But I'm going to modify this a little bit and do regSVR32 and PowerShell.exe. Now, one interesting thing to forget, my just doing PowerShell here is a good example of a high fidelity and a good detection. Looking for the actual path of PowerShell is not a good detection. And why is that? Why is looking for /Windows, /System32, /Windows PowerShell, /version 1.0, /PowerShell.exe a bad idea to look just for that? We went from anywhere, but what else? What else is there?
Too specific.
What's that? Too specific. Who said Syswell? Syswell. So you're missing Syswell 64, which is the 30 ability for Windows 64-bit platforms. And so when you look for Windows PowerShell version 1.0, you're only looking for PowerShell.exe 64-bit. Most attackers, when they're trying to deliver shellcode, will only use Syswell 64 because they can compact 32-bit shellcode on a native 64-bit platform. So this is actually a technique that I created. It's called the Syswell 64 downgrade attack. And it's pretty cool when you say I created this specific attack technique that's being used by hackers all over the world. It's not a good thing, unfortunately. I'm a little bit more responsible nowadays in my older age, but what's interesting with that specific one, and what happened is a guy named Matthew Graber, Manifestation, created a way to do shellcode injection directly from PowerShell from a one-liner, basically. And what it would allow you to do is take your shellcode, and you could pack, let's just say, Metasploit into it, and PowerShell then would inject into the PowerShell process, allocate memory, inject into that PowerShell process, and then execute that code. Okay. Now the problem with that, though, is if I'm targeting a 64 or a 32-bit platform, I would have to run it twice, and then you get an error message that pops up because PowerShell crashed because you're trying to inject 32-bit shellcode in a 64-bit process. And so I came up with the concept of, well, why don't we profile to see if we're in a 32 or 64-bit, and if we're in a 64-bit, just downgrade the process with Syswell 64 to a 32-bit process and run our shellcode directly into there. And what that does now is allows us to have one native command line that allows us to inject shellcode directly into memory. And so with those specific pieces, if you're not looking for the Syswell 64 location, you're probably not going to see it. Another good detection, by the way, to look for that you can do directly from Sysmon, that wasn't me, is you can do this from what's called image load type 7s. Image load type 7s I mentioned before are where you can look for any DLLs that are being imported. If you're not familiar with PowerShell, PowerShell.exe is just a hollow executable. It's not actually PowerShell. PowerShell is actually two DLLs. You have system.management.automation.dll and system.management.automation_na.dll. And those two DLLs are what actually make up PowerShell. Now, a good detection is if I see, if it, here image condition contains system.management.automation.dll and system.management.automation_na.dll and does not include PowerShell.exe, what does that mean? Rename PowerShell, or somebody's trying to call PowerShell. There's a tool that one of our folks made at Trusted Sec called NPS, non-PowerShell. You can go to our GitHub, github.com/trustedSec/NPS, and it's a PowerShell or an executable or a C# loader, and it'll allow you to leverage full-fledged PowerShell without ever calling PowerShell in the first place. So again, new detection rules that you could write looking for those specific areas directly into Sysmon. In this specific case, all we're going to do is we're going to look for Registry 32 being called or PowerShell being called a network connection. So let's go ahead and save this.
Dave, you mentioned that you will often PowerShell reference the hash instead of the executable name. Is that also just to avoid or detect the null?
Yes. Yeah, so if you look for the PowerShell binary, the hash that is in Windows 10, which doesn't change that often, it's not often, and they list all of those. If you look for those hashes in the non-locations of where PowerShell is at, so not under System32, not slash Windows PowerShell slash version 1.0, it's just Syswell 64. That's a pretty good detection because someone may rename PowerShell.exe to something else and then launch from somewhere. A good way to evade Carbon Black, by the way, is copy PowerShell.exe to C:// and then run PowerShell from there. You're fine. So, you know, a couple of decent ways to kind of get around certain detections that you have out there, right? So ways to kind of circumvent. Testing2.xml. We'll go ahead and import this in. Oops. All right, so our new configuration has been updated. And this time what I'm going to do, instead of running registry32, I'm going to run Unicorn. Now, Unicorn is an open source exploitation framework that I created in PowerShell. It's in Python, but it creates a one-liner of obfuscation and evasion techniques. One way that a lot of people will detect PowerShell is through a thing called encoded command, and it's a way to get around what we call execution restriction policies. There's 4 remote sign and something else. And so with encoded command, we can basically take our code, cast it Unicode, and then base64 encode it, and then pass it through PowerShell as a one-liner, and it will execute our code. So a lot of times people will look for encoded command in their detection, but you can also do like -en, you can do -ec, you can do -enco, you know, you can abbreviate it as well, so people that are looking just for encoded command, you don't necessarily detect it. And so what Unicorn does is it uses 2 strings to basically reassemble a encoded command, never calls encoded command in the first place, so it gets around the encoded command detections. Then it uses the x86 downgrade attack to inject shellcode directly into memory through PowerShell, compromise the system, and get you full access to the machine itself. So let's go ahead and run this. I'm just going to use Meterpreter. Really quick, are we streaming right now?
No, we're not streaming.
Can you pause the recording for a second? Example of that specific log, if you were to see it, actually got a backup slide for that, which I never do. But registry 32 beaconing out. Notice here we see on the side here where it's going out to. Now, what's one thing that we don't have here? Look at that event log. What are we missing? Command. That's a big one, and that's one of my biggest grievances with this specific event ID is that while we get network connections, we don't get the actual command that I was executing. So leveraging something like process creation to me is probably a little more valuable if you can, and then coupling that with network connections. So if you see event ID 1, process creation, and it has network connections, send those back. You can do that, okay? Here's an example of DNS. If you see a DNS query with regSVR32 in it, another good example. Here's what it'll actually look like. regSVR32 is querying a name, binaryDefense.com. Another good example of getting DNS queries to be able to leverage those. Some good resources. I did this whole thing that I walked you through is a blog that I just wrote at Binary Defense. If you go to Binary Defense, you just look for Binary Defense Sysmon. That'll be the first hit that you get, and it walks you through everything from downloading, installation, configurations, testing, everything. So it has a full methodology of everything we just covered right here. 2 configuration files that I really recommend is Olaf. Olaf built a Sysmon configuration that's nested that allows you to do things in the MITRE ATT&CK framework. So it maps things down to specific areas in the MITRE ATT&CK framework. It's already a built Sysmon configuration file for you. And you also have Swift on Security has a great Sysmon config as well. It's well documented. It has a lot of great comments in it about why it's there. Pretty good, robust configuration file. In fact, if we click on some of these really quick, I'll show you. And we'll wrap this up. So you see here's the latest version here. And notice how commented out. I mean, this is really commented out well. And you can see the different ones that they provide. And I mean, it's a big configuration. I mean, that's already custom. It removes a lot of the noise from Sysmon. Looks for only what you look for. Heavily customizable. So great reference point. And if you're interested in event log forwarding, Microsoft has a great blog post on how to leverage event logs and forward those event logs directly to your syslog server for identifying specific threats. So using a Windows event forwarding to your syslog server so that you can get these specific logs directly to your infrastructure to then build correlations or detections off. Right. Anybody have any questions? Yeah. Just kidding. Just messing with you.
That's not fair to make it
And I'll make sure everybody has these slides too. I'll send them out to the list.
Question, how does this compare to like the EMET? Is that like more defense?
Emmet's pretty dead. Emmet is no longer being developed by Microsoft, unfortunately. So and they've built a lot of the protection mechanisms inside of Windows 10 and above, but Emmet's pretty much dead. They unfortunately didn't keep it going. So end of life. So much different though. So Emmet was more for memory protection exploits, like zero-day exploits and things like that. Real time, yeah. This is more on the detection side of it. So yeah, yep.
Yeah, so like if somebody's running it that is not an administrator, is that
Running what?
like one of these
Yeah.
scripts he's running?
Yeah, that's a clear indicator right there, right? Is somebody running these commands and tools as a regular user account? In fact, I would even venture to say a regular user running PowerShell is a good indicator of something amiss in your environment. If any user is running any PowerShell whatsoever in your environment, Bob in sales does not need a full-fledged programming language. It's a good thing to block, by the way. So using software restriction policies or app blocker or device guard, you can block based on permission sets and groups. So block PowerShell from being run from regular user accounts and let your developers and IT admins and things like that still run it, but block it from everybody else. So absolutely good indicator. Anything else? Thank you all very much. Appreciate it.